In the pre-dawn gloom of late August 1944, a cold dread settled over observation post 4 inches, Pardieu, France. The morning report lay on the desk, its crumpled paper, a testament to the disbelief and fury of the German technical officers of Flak Regiment 155 Watts. The mathematics before them felt like a betrayal, a malicious fiction that defied every law of ballistic science taught in the Reich. 82% destroyed. The number was an insult to logic, a phantom figure that could only be born of Allied propaganda. Yet, through their powerful field telescopes, they had witnessed the chilling reality with their own eyes. They watched as the V-1 flying bombs, Hitler's unstoppable messengers of vengeance, launched flawlessly toward London, only to be inexplicably slaughtered over the English coast. These were not kills from daring fighter pilots in risky pursuit curves, nor were they random encounters with barrage balloon cables. They were being systematically annihilated by anti-aircraft fire that exploded with an unholy accuracy. Ghostly blossoms of fire and steel erupted around the missiles, not on them, swatting them from the sky as if by an invisible hand. At his headquarters, Obergruppenführer Max Wachtel felt the tide of these impossible reports rising like a black flood. The kill rate had climbed relentlessly from 17% in June to an astonishing 74% by early August, culminating in the single nightmarish figure of 82%. This was more than a battlefield anomaly. It was the dawn of a technological shock so profound it would haunt the Wehrmacht's weapon scientists for the rest of the war. What none of them could possibly know was that they were the first witnesses to the battlefield deployment of one of World War II's most fiercely guarded secrets. A technology so revolutionary that it was protected at the same level as the atomic bomb project. The proximity fuse, or VT variable time fuse as the Allies coded, it was systematically destroying Hitler's terror weapon with a precision that German physics said shouldn't exist. The story began 10 weeks earlier on June 13, 1944, exactly 1 week after D-Day. In response to the Allied invasion of Normandy, Hitler had unleashed his long-promised Vergeltungswaffe vengeance weapon against London. At 4:25 a.m. on June 13th, the first V-1 fell on London, landing in Grove Road and Bow, destroying a railway bridge and nearby homes. 6 people were killed, 30 injured, and 200 made homeless. The weapon represented years of German development, a pilotless aircraft powered by an Argus. As 109-014 pulse jet engine carrying 850 kilograms of amytal, explosive at 640 kilometers per hour. It was the world's first operational cruise missile, and German high command believed it would bring Britain to its knees. Major Walter Dornberger, head of the V-weapons program at Peenemünde, had calculated that even with a conservative 25% success rate, the V-1 would deliver more explosive power to London than the entire blitz of 1,940-41. Each V-1 cost approximately 5,000 Reichsmarks to produce a fraction of the cost of a manned bomber mission with no risk to aircrew. At Peenemünde Army Research Center, German scientists had reason for confidence. They had developed advanced rocket technology, created operational jet aircraft, and now fielded the first cruise missile. Dr. Robert Lusser, who designed the V-1's control system, calculated that Allied interception was nearly impossible. The flying bomb traveled at 640 kilometers per hour at varying altitudes between 600 and 700 meters. British fighters needed speeds exceeding 650 kilometers per hour to intercept. To destroy it, they had to close within 200 meters, risking destruction from the explosion. As for anti-aircraft fire, the probability of a direct hit on such a small, fast target was calculated at less than 1 inch, 1,000 shells fired. This wasn't propaganda, but sound ballistic science. Conventional time-fuzz shells required accurate prediction, precise calculation, manual fuse setting, and perfect timing. With the V-1 speed gunners had perhaps 30 seconds from detection to engagement. Obergruppenführer Max Wachtel, commanding Flak Regiment 155 Watts, knew these limitations from both sides of anti-aircraft warfare. During the campaign, Germans would launch 9 521 volts, 1 missiles from ground sites against England, with thousands more against other targets, bringing the total to approximately 25 0 volts 1 second deployed throughout the German war. Within days of the first launches, troubling reports reached German intelligence. British anti-aircraft defenses were adapting with suspicious speed. By late June, the interception rate climbed from 10% to 24% higher than predicted but explainable. Then came July, and the statistics became inexplicable. German technical officers monitoring effectiveness noticed British guns claiming V-1 kills with impossibly low ammunition expenditure. Observers on the French coast witnessed V-1s second flying steadily toward England, suddenly surrounded by flak bursts, then tumbling from the sky, despite explosions occurring too far away for direct hits. Unknown to German intelligence, they were witnessing proximity fuses that turned near misses into kills. The technology had been operational in the Pacific since January 1943, when the USS Helena shot down a Japanese dive bomber with shells that exploded when sensing proximity to targets. The German intelligence failure was comprehensive. The Oslo report of November 1939 mentioned proximity fuse research, but German scientists dismissed it as disinformation. Germany had attempted developing similar technology. Over 30 different designs were researched, but none achieved operational status. German engineers had concluded proximity fuses were impossible. The technical challenges seemed insurmountable, miniaturizing radio transmitter receivers for artillery shells, making vacuum tubes survive 20000 G-forces, creating batteries that could activate after years of storage, and achieving mass production. Yet by August 1944, American factories were producing 40000 VT fuses daily. During the final week of August 1944, the proximity fuse achieved its maximum effectiveness. The British had reorganized their entire anti-aircraft defense system. Guns employed American SCR-584 radar for automatic tracking. More crucially, they fired shells equipped with VT fuses modified specifically for V-1 threats. The Royal Artillery and RAF Regiment had redeployed from North Downs positions to the south coast, creating a concentrated gun belt. This coastal positioning ensured any dud shells fell into the sea, preventing German capture. As V-1s second crossed the English coast, they entered a kill zone where technology trumped statistics. The SCR-584 radar automatically locked onto targets, calculated trajectories, and fed firing solutions to the guns. The proximity fuse contained miniature radio transmitters built with tubes developed by Sylvania Electric and Western Electric. When reflected, signals indicated proximity. Thyrotron switches triggered detonators sending steel fragments through V-1 hulls. On the peak day in late August, coastal guns destroyed 82% of incoming V-1, second, a rate German engineers deemed physically impossible. Reports of 82% interception created crisis meetings at German headquarters. Wachtell suspected sabotage. Emergency inspections found nothing wrong with the missiles. Test firings over German territory showed normal performance. The problem manifested only against British defenses. German experts concluded the British had developed revolutionary anti-aircraft systems, but couldn't determine specifics without captured examples. They tried varying tactics, different altitudes, larger salvos, night launches, weather exploitation. Nothing worked. The kill rate remained devastating. At Peenemünde, scientists faced an uncomfortable conclusion. If the Allies had developed proximity fuses, they had achieved what Germany thought impossible. German efforts to uncover the secret intensified but failed completely. The proximity fuse's security was nearly perfect. Production was compartmentalized across 110 factories. Workers knew only their specific tasks. Even the name variable time was deliberately misleading, suggesting a conventional timed fuse rather than a proximity sensor. By 1944, the American electronics industry's capacity was devoted to fuse production. 22 million proximity fuses would be produced by war's end, costing over $1 billion in the 1,940 seconds. The Crosley Corporation alone produced over 5 million fuses, nearly a quarter of total production. The numbers revealed a staggering industrial mismatch. While Germany struggled to produce V-1s second using forced labor, America transformed its electronics industry for fuse production. Peak daily production reached 4,000 units. Costs dropped from $732 per unit in 1942 to $18 by 1945. Crosley Corporation, which had manufactured radios and refrigerators pre-war, employed 1,000 workers, producing 160,000 fuses daily at peak. Sylvania Electric dedicated its entire vacuum tube research division to developing ruggedized components, producing 4,000 miniaturized tubes daily, 95% of all tubes used. The contrast was absolute. Germany handcrafted weapons in limited numbers. America mass-produced revolutionary technology at an unprecedented scale. Monthly American proximity fuse production exceeded total German V-1 production for the entire war. The proximity fuse represented extraordinary engineering. The device had to survive being fired from a gun 20 grams, acceleration 25 revolutions per minute, spin temperature extremes. Sylvania developed miniature vacuum tubes based on hearing aid designs, but reinforced to survive these forces. Batteries remained dormant for years, yet activated instantly when needed. The fuse contained a miniature radio that transmitted signals continuously. When reflections indicated proximity to large objects, circuits triggered detonation. This seemingly simple concept required solving problems German engineers considered impossible. Quality control was unprecedented. Every fuse underwent multiple tests. Random samples were actually fired in test guns. Rejection rates below 2% demonstrated remarkable manufacturing precision at a massive scale. By September 1944, the V-1 offensive was effectively neutralized. Of 9 521 volts 1 second launched from ground sites against Britain, only 2 515 reached London, killing 6184 civilians and injuring 17981. While tragic, these casualties represented a fraction of German intentions. General Frederick Pyle, commanding Anti-Aircraft Command, calculated that without proximity, Fuze's V-1 casualties would have been 4 to 5 times higher. The proximity fuse saved London from devastation. Germany shifted to night launches and developed the V-2 rocket, which flew too fast for interception. But these desperate measures couldn't achieve strategic impact. The V-1 became a costly failure, consuming resources desperately needed elsewhere. The German failure to detect proximity fuses represented one of history's greatest intelligence disasters. Despite extensive networks and technical expertise, the Germans never grasped what they faced. The program remained secret throughout the war. Not a single intact proximity fuse fell into German hands during the V-1 campaign. Remarkably, during the Battle of the Bulge, German forces captured an American ammunition dump containing proximity fuses but never recognized them. Their assumption that such devices were impossible blinded them to evidence in their own hands. After Germany's surrender, interrogations revealed complete German ignorance about proximity fuses. Obergruppenführer Max Wachtel told Allied officers they suspected improved radar or faster-setting fuses, but never imagined self-thinking shells. German scientists shown captured American VT fuses expressed disbelief. They couldn't comprehend tubes surviving acceleration batteries remaining viable or circuits functioning after gunfiring. They estimated being 10 years behind American technology. Dr. Merle Tuve, who led proximity fuse development at Johns Hopkins Applied Physics Laboratory, later reflected that success came from systematic collaboration between scientists, engineers, and production workers, something totalitarian systems couldn't achieve. The proximity fuse demonstrated that World War II's outcome was determined in laboratories and factories as much as on battlefields. While Germany pursued exotic wonder weapons, America focused on multiplicative technologies enhancing existing weapons. The proximity fuse made every anti-aircraft gun 5 to 10 times more effective. Secretary of the Navy James Forrestal stated, "The proximity fuse has helped blaze the trail to Japan." Without the protection this ingenious device has given the surface ships of the fleet, our westward push could not have been so swift, and the cost in men and ships would have been immeasurably greater. The V-1 program relied heavily on slave labor. Tens of thousands of concentration camp prisoners died in underground factories manufacturing V-1s second. Meanwhile, American workers voluntarily worked overtime for premium wages, not knowing exactly what they produced, but understanding its importance. At Sylvania's Ipswich facility, over 5,000 women worked 12-hour shifts, producing specialized components. They discovered only after the war that they had helped save London from Hitler's terror weapons. The proximity fuse secret held completely. British anti-aircraft crews didn't know what made their shells effective. They had special ammunition with strict accounting requirements. Every proximity foe's shell fired at V-1 second was tracked. Unexploded shells were immediately secured. Naval vessels patrolled the channel, preventing German recovery of duds. This secrecy cost lives. Allied ground forces couldn't use proximity-fused artillery until December 1944. Thousands of soldiers died because the technology was too secret to risk. Yet using them against V-1 second was justified. London's survival during the invasion was crucial. For Germany, the V-1 program drained critical resources while achieving minimal strategic impact. Launching approximately 25 0-volts 1 second, total cost millions of Reichsmarks and diverted resources from fighter aircraft and anti-tank weapons desperately needed on shrinking fronts. The program's reliance on slave labor added a moral dimension to its failure. The proximity fuse was defeating weapons built through human suffering, a contrast fully understood only post-war. The proximity fuse represented warfare's transformation victory through engineering and production rather than individual weapon superiority. It proved modern warfare was a contest of industrial systems, not just military forces. Before saving Pacific Fleet ships and enabling Japan's defeat, the proximity fuse saved London. Germans watching V-1's second fall never understood why. The technology that defeated them was inconceivable within their scientific framework. The transformation was dramatic. Before proximity fuses destroying a V-1 required an average of 2 500 heavy anti-aircraft shells. With proximity fuses, this dropped to 100 shells. The gunbelt's interception rate rose from 17% to 82% in 10 weeks. This wasn't achieved through courage or training, but through the mass production of advanced technology on a scale Germany couldn't match or comprehend. America had mobilized its entire electronics industry, employed over 8,000 workers, and invested over $1 billion to produce 22 million fuses. The proximity fuse was declassified in September 1945. The War Department announcement began. One of the most important weapons developed during the war, surpassed in effectiveness only by the atomic bomb. For the German scientists who had puzzled over V-1 failures, the revelation brought understanding and humiliation. They had been defeated not by strategy or courage, but by an industrial capacity they hadn't imagined possible. Post-war interviews revealed German shock. They had believed their V-1 represented the pinnacle of weapons technology. Learning it was defeated by mass-produced electronics costing less than $20 each was devastating. They had lost not to warriors but to assembly lines. The proximity fuse technology evolved into modern air defense systems, radar altimeters, and electronic warfare capabilities. For Germany's former weapons scientists, it remained a permanent reminder of their wartime blindness. The proximity fuse proved that in modern warfare, mass-producing good technology matters more than crafting perfect weapons. Germany produced brilliant individual weapons. America produced effective weapons by the millions. On that remarkable day in late August 1944, when proximity fuses destroyed 82% of German V-1, second, the nature of warfare changed forever. The Germans launching their vengeance weapons never knew what invisible technology was defeating them. They had done everything right by their understanding, developed advanced weapons, trained elite crews, achieved breakthroughs. Yet, they were defeated by mass-produced electronics they couldn't imagine. The proximity fuse saved London through thousands of small explosions, each guided by technology German science deemed impossible. It was industrial democracy's triumph over totalitarian engineering, mass production over crafted perfection, and multiplied simple solutions over complex wonder weapons. The Germans never discovered what hit their V-1 second as they fell burning from the sky, defeated by a secret they couldn't conceive and an industrial might they couldn't match. Of course, here is the conclusion translated into American English. You made it, B? The proximity fuse had turned Hitler's vengeance weapon into London's salvation, and the Germans never understood how or why until long after it mattered. Their failure lay not just on the battlefield, but within their scientific framework. After the war, when confronted with the technology they once deemed impossible, German scientists faced a humiliating truth. They had been defeated not by courage or strategy, but by an industrial capacity they couldn't fathom. The shock of learning that the V-1, the pinnacle of German engineering, had been neutralized by a mass-produced electronic device costing less than $20 was a devastating blow. They had lost the war not to warriors but to assembly lines. This victory represented a profound transformation in the nature of warfare. It proved that in the modern era, mass-producing a technology that was good enough was more important than crafting perfect weapons in limited numbers. Germany created brilliant individual weapons. America produced effective weapons by the millions. That remarkable day in late August 1944, when the proximity fuse destroyed 82% of Germany's V-1s, proved that a democracy's ability to mobilize science and industry could overcome the forced brilliance of a totalitarian regime. In the end, America's greatest victory wasn't on the battlefield, but in its factories, where millions of workers, many of them women, who never knew what they were making, produced the tiny electronic devices that saved a city, transformed warfare forever. The 82% interception rate stood as proof that in modern war, industrial capacity could defeat any wonder weapon. The proximity fuse was more than a weapon. It was a declaration.